Bright Tuty. Every student matters.
Hello dear students, today we will be taking up the first chapter of 9th class physics, that is motion. Alright. Now, okay, the first question that comes to us is, an object has moved through a distance. Can it have a zero displacement? If yes, support your answer with an example. So students, can it have a zero displacement? Displacement, not distance. Distance can never be zero, right? Can it have a zero displacement? Of course, yes. And how it can have a zero displacement? When its initial position and the final position are same. Support your answer with an example. You can take the example that we have taken above. Firstly, from point A going to point B, going to C, and then coming back again to point A, right? Or we can just take a very specific example that we are moving from our house to our school in the morning, and in the afternoon we are coming back to the house. So if we talk about our displacement, it is zero. Another example, that circular motion that we have taken, jogging in the or walking in the circular path, taking one complete turn, that is also displacement zero example, right? Fine. Now let us take one more example. Now this is quite interesting, try to relate it. A farmer moves along the boundary of a square field of side 10 meters. Now what exactly is given to us in the question is that this is a square field. Now the side of 1 is given to be 10 meters. It is 10 meters, and we know that if it is a square, all the sides will be of 10 meters, right. Let us say from this particular initial point A, the farmer has started moving and it has moved along this particular side 10 meters in 40 seconds, right. What will be the magnitude, that is the amount of displacement of the farmer at the end of 2 minutes 20 seconds. Now when I talk about 2 minutes 20 seconds, I know that 1 minute is equal to what? 60 seconds, right. If I talk about 1 minute, that 1 minute is equal to 60 seconds, and 2 minutes should be equal to 120 seconds plus 20 more, so that comes out to be 140 seconds in totality. Now 140 seconds we see in totality. So what we are asking is how much distance this farmer is going to move at the end of 140 seconds. He is moving along the boundaries of this square field, right. He is not moving in a straight direction. This is what we need to relate in this particular question. Now if in 40 seconds he has travelled these 10 meters and he is moving along the boundary, 40 seconds, let us relate, he has moved from A to, let us say, this point B, this is C, this is D, right, from A to B. Now if he is moving along the boundary, in the next 40 seconds he will move from B to C, from B to C. A to B was 10 meters, B to C is 10 meters again, this is next 40 seconds. Then in the next 40 seconds he will be moving from C to D, that will be another 10 meters, right. Now this is 40 plus 40 plus 40, 120 seconds. Next 20 seconds when he will be moving at the same level, but from D to A, and probably because this is 20 seconds, that is why we will relate that he will cover half of the distance, that is till E. If D to A was 10 meters, let us take half of it, 5 meters. So from D to E he has travelled 5 meters. So this is what actual path he has travelled in these 2 minutes 20 seconds. Got it? Now had it been in the question, It is not actually, I am just trying to relate it to you. Had it been in the question that what is the distance travelled by the farmer in these 2 minutes 20 seconds, we would have added all these 10 plus 10 plus 10 plus 5. That means it should have been 35 meters. That is the answer if we have been asked the distance travelled. But in this particular question, what he is asking is what is the amount of displacement. Now, if we see, the initial position of the farmer was A, and after 2 minutes 20 seconds the final position is E, and the shortest distance between A and E is actually 5 meters. So, the magnitude of displacement of this farmer travelling along the boundary of this square field having 10 meter side after 2 minutes 20 seconds will be 5 meters. Understood, students? Fine. Nice question, huh? So, this is what distance and displacement is. Let us take another example. Let us see. Now, this is also a good question. Let us try to relate it. Let us take initial point A. Fine. We know the directions. We know that this is north direction, this is south direction, this is west direction, this is east direction. All of us know it, right? Let us see the question. A man travels a distance. Let us see the question. A man travels a distance of 5 meters towards east. Now, east is this direction. If starting from this particular A, I will say that this is the east direction and these are the 5 meter distance he is travelling. Let us say from point A to point B, right. These are the 5 meters he has travelled towards east. Then 5 meters towards south. Now, he is at the moment he is at this point B. From point B, he has travelled another 5 meters south. South, that means in the downward direction. Let us take this position to be C. So, now after going 5 meter towards south, this particular man is at this particular point in time at position C. And finally, 5 meter towards east again. At this particular point, his east is 5 meters here. At this point D, this is 5 meters. Got it? Fine. Now, what we are going to calculate is what is the total distance travelled. We know that the total distance is equal to the actual path covered by this man, and the actual path he has covered is from A to B, then plus B to C plus C to D point, which is 5 meters plus 5 meters plus 5 meters, which comes out to be 15 meters in totality. This is our answer of first part of this question, that is the total distance travelled. Now, he is asking what is his resultant displacement. Now, when I am talking about displacement, I need to find the shortest distance between the initial point and the final point, or the initial position and the final position of this man. This man has started from this initial position A, ended up in this final position D. So, if I want to know the shortest distance, what I will have to do is I have to join this particular point A and this particular point D. This should be a perpendicular distance. So, I need to find this AD. Now, how I am going to find it? I will try to relate with a construction. What I will do is I draw a perpendicular here from A, right, and once again I draw perpendicular and join this particular point, and let us give it a point O. Now if I try to relate, this is point A, this is O, and this is D, and if I relate, now this is a right angled triangle, right? Fine. Now in this right angle triangle, this AO will be the perpendicular, this OD is the base, and this AD is the hypotenuse, right? So by Pythagoras theorem, you must have studied Pythagoras theorem in your maths, and if you haven't, you will. This Pythagoras theorem relates that the square of hypotenuse is equal to the sum of the square of the base and the perpendicular in a right angled triangle. I repeat, according to the Pythagoras theorem, the square of the hypotenuse, which is AD, is equal to the sum of the square of the base and the square of perpendicular. If we talk about this our particular figure, then the hypotenuse is AD. So I will relate that AD square will be equal to the base is OD, the square of OD, plus perpendicular is OA, the square of OA, right? This is what now my formula or equation, whatever you call it, will become. If we relate, then this OA is equal to BC, and if this BC is 5 meters, this OA I can also write the value to be 5 meters. So I can write 5 instead of OA square, plus now this CD is given to us to be 5. When we try to observe and relate this OC, we see that this OC is equal to AB, and since AB was 5 meters, this OC should also be 5 meters. Now OC is 5 meters, CD is 5 meters, so O to D will be this OC plus CD, or 5 plus 5, that is equal to 10 meters. So instead of writing OD, I can write 10 meters. So now my AD square or the hypotenuse square will be equal to OD square, which was the base, and the base we have seen it is of 5 plus 5, 10 meters. Again OA square, OA is our perpendicular, which is 5 square. So now just simply calculating it, I'll just calculate. 10 square is 100, 5 square is 25, it comes out to be 125. This is AD square, right? Now if I need to calculate AD, so now I have seen that AD square is equal to 125, and if we need to find out AD, we will take square root of 125. We know the concept of square root. This is 125, I can just take it to be 5 into 5 into 5. Now if I am taking a square root, this 5 into 5 can be brought out. So this will be 5 square root 5. And since I am talking about displacement, it will be in meters. This is my AD, or this is the displacement of this particular man that we have taken from this particular point from where he initially started. Got it? So this is how we calculate the distance as well as the displacement of any particular object. Alright, let us see. An athlete completes one round of a circular track of diameter 200 meters. So let us take a circular track, and the diameter of this circular track, let this be the center O. The diameter of this circular track is 200 meters. So that means this portion, which is the radius, it should be half, it is 100 meters, and another, this part of the diameter, this radius is also 100 meters, and this hole is 200 meters. And an athlete is completing one round of this track in 40 seconds. Now, let us say that the athlete started from this point A and he went along the path of the circular track, what we call is to be the circumference of this circle, right, and he is completing one complete circumference in 40 seconds. So, when I talk about the distance travelled in these 40 seconds, which will be equal to the circumference of the circle, and we know the formula of circumference is 2 pi r, where pi is 3.14 or 22/7, we already know it is a constant, and r, the value is given to be 100 meters radius of the circular this track, right, and for this he is taking a time of 40 seconds. Now, what we are being asked in the question is, what will be the distance covered and displacement at the end of 2 minutes 40 seconds. Now, what he is asking is, how much path or the distance will these athlete cover in these 2 minutes 20 second time, and where exactly he will be finally positioned after the end of 2 minutes 20 seconds, because that is what displacement is. Now, when we talk about 2 minutes 20 seconds, we see that 2 minutes are equal to 2 into 60 seconds means 120 seconds, and another 20 seconds. So, if I relate, I see that these are actually 140 seconds time, right. Now, this athlete, try to relate, in 40 seconds time, in the first 40 seconds, this athlete is travelling a distance of one circumference of the circle, that is equal to 2 pi r. In another 40 seconds, he is covering another distance of 2 pi r, one more round of the circular track. In another 40 seconds, he will be covering 2 pi r, and in another 20 seconds, he will be covering half of the track. So, if it is half of the circumference, I will take it to be pi r, right. So, at the end of 140 seconds, this particular athlete has covered or travelled a distance of 2 pi r plus 2 pi r plus 2 pi r plus pi r, comes out to be 7 pi r. Putting the value of pi and r, I know that pi is equal to 22/7 and r is given to be 100 meters. Cancelling 7 with 7, I get the total distance covered by this athlete in 2 minutes 20 seconds will be 2200 meters. This is the distance covered by the athlete. Clear? Now, talking about the displacement. Now, in the first 40 seconds, this athlete is starting from A and he is taking a full turn coming back to A, first turn. Another 40 seconds, he is once again coming back to A, second complete turn. Third time also another 40 seconds, third complete turn. Now, when we are talking about the next 20 seconds, from A, this athlete is able to cover half of the circumference. That means, after 20 seconds, he will be, let us say, at this point B, completing 3 full turns, and the fourth is the half turn, right. Now, from this A to B, we need to see exactly this will be his total displacement, and as we can see, his total displacement is actually from A to B, and this is the diameter of this circle, and this diameter is given to us, that is to be 200 meters. So, simply this 200 meters will be the displacement of this particular athlete, right. So, these are a few questions based on our distance. Hope you have understood all these. Please try to relate, please try to do them, please try to practice, otherwise you will forget them, right. Thank you very much.